In this video, I'll be showing how to evaluate inverse trig functions. So we'll focus on the inverse of sine, cosine, and tangent. And before we do any evaluation, let's remember how we restrict the domain for each of these inverse functions. We restrict the domain because we want the function to be a one-to-one function, so that when we find the inverse is also a function. So for the inverse sine of x, we restrict the output values y to be between negative pi over 2 and pi over 2. You can think of this graphically as anything, if we're thinking about the unit circle is a circle with a radius of 1. So this point in radians is pi over 2. This point down here is negative pi over 2. So when we restrict this, we're talking about this area or this region here. So it's kind of like we're talking about quadrants 4 and quadrant 1. And then let's think similarly about the inverse of cosine and the inverse of tangent. So for cosine, we restrict the output to be between 0 and pi. So that is going to be this, anywhere in this area. So between 0 and pi. And because I didn't mention this for sine, but we're going to include those endpoints. And then for tangent, we're between negative pi over 2 and pi over 2, but we don't include those endpoints. And the reason we don't include those endpoints is because the tangent is undefined at those locations. So for cosine, we can think of this as quadrant 1 and quadrant 2. For tangent, similarly to sine, we can do quadrant 4 and quadrant 1. So let's actually find or evaluate some of these inverse trig functions. All right, we'll look at the inverse of sine first. So the first one says sine inverse of root 3 over 2. What this is saying is, what angle has a sine value of root 3 over 2? And we're going to find all these angles in radians. So sine is positive in quadrant 1 and 2. And sine is equal to root 3 over 2 at these positions. So that is pi over 3, and this is 2 pi over 3. The coordinates are 1/2 root 3 over 2 and a negative 1/2 root 3 over 2. However, thinking back to what we saw over here, we only want what's in quadrant 1 or quadrant 4. So we're going to use the value that's in quadrant 1. So this is going to be pi over 3. Number 2, let's go back to number 1. We only want to give one angle value here. We must only give pi over 3. We don't give both of those angles because a function, when we have an input into a function, it should only give a single output. All right, arcsine is equal to negative 1/2. Again, this is saying what angle has a sine value of negative 1/2. Now, arcsine, that's kind of an outdated way of writing the inverse, but it means the exact same thing. Arcsine is the same thing as sine inverse. And where that's coming from is it's relating the arc length and the interior angle and the length of the arc. So what angle has a sine value of negative 1/2? So sine is negative in quadrants 3 and 4. It's going to be in these positions. So sine is negative 1/2. This is negative root 3 over 2, comma negative 1/2, and positive root 3 over 2, negative 1/2. Those angles in radians are 7 pi over 6, 11 pi over 6. So again, thinking back over here, we want what's in quadrant 4, not quadrant 3, so we're going to use this position. However, 11 pi over 6 is not between negative pi over 2 and pi over 2. So it's tempting to write 11 pi over 6, but 11 pi over 6 is bigger than this endpoint. So instead of going all the way around the circle to 11 pi over 6, we're going to go this distance here. And instead of writing that as 11 pi over 6, we're going to say negative pi over 6. Lastly, sine inverse of negative root 3 over 2. What angle has a sine value of negative root 3 over 2? Again, sine is negative in quadrants 3 and 4. This is going to be 1/2 negative root 3 over 2, sorry, negative 1/2, and positive 1/2 negative root 3 over 2. From what we've seen, we want this position, okay? And our first thought might be to say 5 pi over 3, but instead we're going to say negative pi over 3 because we want it to be in this range. So negative pi over 3. So let's evaluate some inverse cosine functions. Back to what we saw, we're going to stick to angles in this region here. And so the first one is saying cosine inverse of negative 1. It's saying what angle has a cosine value of negative 1/2. Now be careful, this is a coordinate. So we're looking for the angle where cosine has a coordinate of negative 1. And that is going to be over here because the coordinates there are negative 1, 0. So cosine is equal to negative 1 there. And that angle is pi. So this is equal to pi. The next one says cosine inverse of negative root 2 over 2. Cosine is negative here and here. Negative root 2 over 2. Negative root 2 over 2 comma positive root 2 over 2 are the coordinates. And then these are both negative. But again, we want to be in that green shaded area. That angle is 3 pi over 4, which is between 0 and pi. So that's what we want for this one. And then lastly, arc cos of negative 1/2. This is just saying what angle has a cosine value of negative 1/2. And that is going to be, let's do this in red. It's going to be this position right here. The coordinates there are negative 1/2, positive root 3 over 2. Cosine is the x-coordinate, so it's that position, and that angle is 2 pi over 3. 2 pi over 3. All right, and then for inverse tangent, we're going to be in a similar area as what we saw for sine. So tangent inverse of 0, this is saying what angle has a tangent value of 0? Well, let's recall tangent, we can think of that as y over x, or sine over cosine. Either way, probably y over x makes the most sense for this type of problem. So for y over x to be equal to 0, we need a y value of 0. So it's going to be at this position right here. So what is that angle? Well, the range for these angles for the shaded part is negative pi over 2 to pi over 2. So that angle is just 0. So this one is actually equal to 0 and radians, just to make it clear that we're talking about an angle there. Arctan of negative 1, this is saying when does tangent have a negative value of 1? So for tangent to be equal to negative 1, the sine and cosine values, or the y and x, must both be the same. So we're at root 2 over 2, comma negative root 2 over 2. And our initial thought may be to say, well, that is equal to 7 pi over 4. But that is not in the restricted area. So we instead write negative pi over 4 here. And then this last one, tan inverse of negative root 3 over 3. So tangent is negative between quadrants 2 and quadrants 4, but quadrant 4 is where we are restricted to. So it's going to be at this position right here. Those coordinates, I'm kind of running out of space, but those coordinates are positive root 3 over 2, comma, negative 1/2. So the y value over the x value, we get negative 1/2 over root 3 over 2. We can simplify the 2's and then multiply the top and bottom by root 3. We get negative root 3 over 3. So that does in fact correspond to this position. And that angle, we might be tempted to say 11 pi over 6, but we want to, instead of going counterclockwise, we want to go clockwise and just do this angle right here. So that angle is going to be negative pi over 6. All right, the last thing we want to look at here are compositions of trig functions. And for these particular ones, we're going to have inverse and regular trig functions. So we need to remember for regular trig functions, what the inputs are and what the outputs are. So for a regular trig function, the input is going to be an angle. This could be in degrees or radians. The output is going to be a coordinate. For the inverse, these are swapped. So for an inverse trig function, the input is a coordinate, and the output is an angle. So this is helpful as we're evaluating these. All right, let's look at the first one, sine of negative pi over 4. Well, negative pi over 4, this is a regular trig function, so the input there is an angle. So sine at negative pi over 4, that is equal to negative root 2 over 2. So we're going to say sine inverse negative root 2 over 2. Okay, this negative pi over 4 is in quadrant 4. So sine in quadrant 4 is negative. All right, so now we're saying sine inverse of negative root 2 over 2. Well, this is occurring in quadrant 4, so it's actually the exact same angle that we started with. Why don't I kind of show what's happening on the graph. So negative pi over 4 is down here, and that has a coordinate of negative root 2, or root 2 over 2, comma negative root 2 over 2. So sine at negative pi over 4 is this value right here, and then we're going to input that, we're going to input that value here, and so we're saying sine of what angle has a value of negative root 2 over 2, and it's right back to where we started. This won't always be the case, but in this particular instance it is. All right, next we have sine of cosine inverse of 1. So because we have an inverse function here, we want to think about what the input is. The input is a coordinate, so 1 is a coordinate. And what this is saying is cosine of what value is equal to 1. So where is cosine equal to 1? Well, cosine is equal to 1 in this position right here, and that has an angle of 0. Okay, so 0 degrees or 0 radians. So then we're going to say sine of 0. So now sine of 0, this is a regular trig function, the input 0, that is an angle. So we're saying, what is the sine value at 0? Well, the coordinates at 0 are x is 1, y is 0. So sine of 0 is equal to 0. So that would be our final answer here. All right, lastly, we have cosine of tangent inverse of root 3 over 3. Well, we already found tangent of root 3 over 3 I guess we found tangent inverse of negative root 3 over 3. So let's do tangent inverse of root 3 over 3. That's going to occur at this position, which is pi over 6. Those coordinates are root 3 over 2, comma 1/2. When we do y over x, the 2's cancel, multiply the top and bottom by root 3, we get root 3 over 3. So tangent inverse of root 3 over 3 is going to be pi over 6. So cosine of pi over 6, what is the cosine value, or the coordinate that corresponds to cosine at pi over 6? That is root 3 over 2. Alright, so that's it for this video.